So I should probably start at the top. So today's talk is on Conda-Vendor and how to create portable Conda channels with this tool. So I was a co-author of this tool. It's an open source tool that can be found on Conda-Forge, pip, and then the source code is on GitHub. So a little bit about myself. I'm a software engineer at Quansight. I'm passionate about DevOps, system architecture, Emacs, and various other things. I'm a contributor to several different open source projects, the main ones being QHub, Conda-Forge, and Conda-Vendor. And then I also personally live about an hour outside of Austin, Texas. So these are some of my neighbors that I ran into a few days ago when it was snowing and also when I was trying to leave my house. So I really enjoy that kind of duality of technology and living in the country. So Quansight, just want to mention a little bit about the mission of Quansite. The mission is to enable a robust open source data economy. We do this by providing consulting and development services, obtaining corporate funding for open source communities, and by managing early stage investments in business that use open source software. So if you want to reach out, be happy to have you. So environments, what's the purpose of having them? So specifically, Conda environments is the focus of this tool, but there's many other different tools out there that handle environments. But all of them are trying to do the same thing, which is enable developers to have a set of software packages to run their code. So specifically for Conda, there's a couple of things that make it stand out compared to other environment management tools such as pip. So the first is reproducibility. So with Conda environments, there's this concept of a Conda YAML file. An example is down here. And you can specify Conda packages. You can even pin the version, such as here, we've pinned this particular Python version to 3.10. And you can have more confidence that other users will be able to run your same code if you can share an environment that they can pull on their own machine. The other is package version management. So Conda enables you to upgrade your packages, and along with version management, it makes sure that your package versions and the dependencies that it relies on all resolve and play nice together. I think a lot of us have had the experience of installing a new package and then having it error out because there's some incompatibility with a subdependency. So Conda does this a little bit differently than some other package managers, and it has some benefits. So one of those big benefits is multi-language support. Conda doesn't only support Python, but it also supports C++ and various other languages. It also has support for Windows, Linux, and OS X. Conda is the main package manager used by a lot of the scientific community, so there's a lot of work that goes into Conda and the packages there. And the other thing is that compiled libraries are actually supported natively on Conda. So unlike pip, where you can install something and then be required to install, another library separately on your own, you're left up to your own devices, Conda enables you to download that at the same time. So this brings us to Conda-Vendor. Why did we need Conda-Vendor if Conda is so awesome? Well, Conda is built on the idea that you can just reach out to a channel which has all of these packages. There's a main Conda channel given by Anaconda. There's also another very popular channel called Conda-Forge, which is an open source channel where you can submit packages of your own to there. And the issue with these channels is they're huge. They can be many gigabytes in size. And the particular problem we were trying to solve is how can we get packages inside of an air-gapped system? So the air-gapped system we were trying to add packages to had several limitations. There was a big security process that had to be gone through for every single package that went into there. So it was not feasible to just pull all of Conda-Forge inside of our system, not only from a size perspective, but you would have to submit a security report for tens of thousands of packages, and that just wasn't feasible. So the solution was to create little chunks that were taken out of these main channels. And we could do that with some other tools, but none of them like gave us the full automation. There's a lot of like hand programming to specify what specific packages we wanted from the channel, and we wanted to automate a lot of this. So what is Conda-Vendor? Conda-Vendor automates the creation of Conda channels. So first, the first main idea is that it solves your environment from a Conda YAML file. So if any of you are familiar with Conda YAML files, like I showed in the other slide, there's a list of packages, and it will solve all of the dependencies for those packages and download them to your local computer. And then it also filters the repo data.json. I'll talk a little bit more about what that means. But this is the JSON file that specifies all of the dependencies for your packages. And so in order for Conda to do a solve, it needs that repo data.json to say, okay, NumPy, relies on Python version 3.8 or above. And then the third thing it does that we couldn't find other places was that it generates a customized security report based on all of the packages that were downloaded. So this is an architecture diagram for Conda-Vendor. This left side here is the typical flow for a Conda install. So right here, we can see the structure of what a Conda channel is. So a Conda channel is simply a well-known file structure. So you'll have a root folder, and inside that root folder, you'll have subfolders which contain all the packages for the different architectures. So NoArch in this case is no architecture. So those are platform agnostic packages. Linux 64 is for packages for Linux, and then you might have OS X or Windows. In a normal Conda install, what happens is you say, hey, I want to create this environment, and I want package 1, package 2, etc. So it pulls this repo data.json file down, and Conda will look at that repo data, look at the packages that you want to install, and then look at all the dependencies for these packages and figure out which packages are compatible with each other so that you can download those packages and they'll all work together. And when it finds a successful solution to all the packages that you'd like, it will download those to a local Conda environment. For us, we leveraged some of the mechanics of Conda in order to create a local channel down here. So what we did is we pulled the repo data.json, we used that same YAML file and said, hey, let's solve the packages that are needed to get this list of packages you specified. Based on that list of packages, we download the actual package tarballs themselves. We create the directories for those packages that are relevant, such as Linux 64 and NoArch. We also save a subset of the repo data.json. So whenever you download and create an environment, you'll reach out to the channel that you're installing from, so in this case, main, and it downloads the entire repo data.json. And that's about a 60 to 80 megabyte JSON file that contains metadata for all of the packages in that channel. And for us, we only wanted to have a subset of that repo data.json and only the packages that were specified from our solve. And so what you have as a result is basically a cookie cutter chunk taken out from your upstream channel that contains only the packages that you need to recreate your environment and only the metadata of those packages that you need to recreate your environment. And so now you have a local Conda channel that you could install without the internet. The other thing that Conda does is it enables you to build a security document to get these packages reviewed by whatever security operations process you have in your company or your organization. And so the way we did this is we created a generic meta manifest.json file. So for us, all that really means is it's a big YAML or a big JSON file that contains all of the packages and all of the details about those packages so that you have all the raw materials you need to create a security document in the future. So for us, the organization we were aiming for was Iron Bank. And so they had a particular requirement where they wanted the name of the package, the URL to download that package, and the SHA-256 hash of that package. And so that's what we added to the library first. We did create a mechanism so that other other versions of this security report could be created, but for now, the Iron Bank version is the only one that's implemented. So on to the demo. So I wanted to show a little bit of a demo here. So this is how you would start when you're creating a channel with Conda-Vendor. You would create a YAML file, and this is just a typical YAML file that you're using to create a Conda channel, and you specify the packages that you want, and you can optionally specify the package version. And then, so I'm going to create and show you how to install Conda-Vendor. So to install this, I'm going to do a conda create. I'm going to give this a name, and I'm going to call it vendor demo. And our package is hosted on the Conda Forge channel. So I'm going to say Conda Forge, and then I'm going to say Conda-Vendor. So this is going to install the Conda-Vendor package on my computer so that I can actually run this demo. So I'll take a moment. I'm going to say, yes, I want to install all of these things. And now I have Conda-Vendor. So let me go ahead and activate this environment. So now we have Conda-Vendor, and we can verify we have it by just looking at the help here. We can also see the version. Great. So now if we look in this folder, I'm going to get rid of everything else besides this environment file. So now we just have this environment YAML file. So the first thing we want to do is create the meta manifest file. And kind of going back to here, and I can use this as reference. This meta manifest is the raw materials that tells both Conda-Vendor and the custom manifest how to create the channel, as well as how to create the security document. So I'm going to do Conda-Vendor manifest and give it the path to the file. And that file is right here. Give me a moment because I can't remember the own commands that I wrote. Meta manifest. All right, so what this is doing is this is taking this channel here, and it's saying, okay, in this, it's taking this environment YAML, and it's reading it, and it's saying, I see there's 4 packages here that this user is requesting. And then it's performing a normal Conda solve to figure out how to resolve that and download the required packages. I think in this case, this is solving something else. Let me redo that. There we go. So we see Python 395, we see pandas 141, and then matplotlib. One thing to note is that Conda by default, whenever you install Python, it automatically adds pip. And that was an issue because by default, the libraries we're using here didn't install pip. So to get around that, we just kind of made the same decision that Anaconda did, so that anytime you install Python, it's also going to add pip to the dependency list. And so what this is doing, if we go back to our diagram here, is it's solving this and outputting this meta manifest. So this will take about 60 seconds, and then we can continue. Perfect. So now we have a meta manifest file. And if we look at this file really quickly, we can see that this has all the information about these various files. So if we look at the names, for example, this is wheel, and we can see all the dependencies for it, the license, the MD5 SHA hash. I think there's the SHA 256 as well. And there's all of these for every single dependency that was required by the 3 packages we wanted to install. Okay, cool. And then the next thing we want to do is create a local channel from this. So if we look at our available commands again with the help, we can create a channel, which is this first option. So Conda-Vendor channels. And we're also going to pass the path to the meta manifest file. And actually, I'm going to do this with a little verbose logging so we can see it download the packages. So what this is going to do is every single time it's going to iterate through this meta manifest file, and it's going to look at all of the URLs for these packages, and it's going to download them all. And it's also going to make sure it downloads them in the proper location. So for example, we can see there's a no arch key here, and there's also going to be a Linux 64 key. And so I'll show in a moment, once this finishes downloading, what that structure looks like. But this will essentially be a local channel. To kind of reiterate a little bit, the local channel looks like this. So that no arch key you saw there is going to have a repo data.json specific to the no arch packages. And then it's also going to have the actual packages themselves. And a similar thing will happen with Linux 64. We'll have the repo data.json that applies to the Linux 64 packages along with the package data themselves.
So overall, this just kind of grants you more flexibility in terms of managing your packages. You have the same access to all the same packages, but you can create security policies. Is that kind of the general idea?
Yeah, and it also enables you to access your packages and do Conda solves when you don't have access to the internet. So this was built with air-gapped systems in mind, which don't have access to Conda Forge or to like the main Anaconda channel. So in order to do Conda installs, we needed a way to like bring those channels over the gap.
Okay.
So like one of the motivations was that over time, as we did multiple iterations of sending these Conda channels, you could somewhat hydrate your air-gapped system with multiple versions of packages.
Cool.
So like yeah. Thanks for the question. So if we look at the tree here, we can see this Linux 64 directory, which contains all of the packages that are related to Linux 64. And there will be like a repo data for Linux 64 and the same thing for no arch. Repo data for no arch. So this is like a completely usable channel now. And so I can kind of show you how to use it. So if I change my environment file here to, let's see, this should be /local channel /local Conda Forge. And then I'm also going to add no default so it doesn't try to reach out anywhere else. I do conda env create. Make sure that's saved. And then I'm going to give this like a prefix. So this isn't actually downloading packages at this point. It's just unpacking them from my local Conda channel into this new environment I just created. And I can prove that in a moment once it finishes extracting these. Great. So now let's activate this new environment. Now we're in this new temp/test environment, and I can do a conda list --explicit. And we can see that all of these files are coming from this local directory. So none of these files were downloaded from the internet. And to kind of show you in contrast what that looks like compared to like a normal Conda environment, we can see here these all have HTTPS extensions. So the last piece is showing how we can go from this meta manifest to this security document. So we already went through this process to create this local channel, and I demonstrated that you can install an environment from that local channel without the internet. Now I'll show the security aspect of it. So this one is Conda-Vendor custom manifest. I'm going to give it the generic meta manifest, and it just created my output manifest.yaml. So if we look at that file, this is the specific format that Iron Bank requires in order to approve packages for their Docker containers. So for them, they wanted to have a top-level resource key and then a list that contained the URL, the file name, and then the validation, which is the SHA-256 hash. And that's pretty much it when it comes to how Conda-Vendor works and what it does. I can say from like personal experience, this has been a very useful tool. So I've probably created, I don't know, over a dozen environments over the past 2 months. And being able to automate this process is very useful. Like I can use Conda-Vendor to output that security document, and what would have taken like 3 or 4 hours and was prone to human error, I can now just do like in however long it takes for Conda to solve that environment, and I'll be off to the races.
For Iron Bank, did they need this for something like a continuous integration, continuous deployment setup that they have?
Yeah,
what was the impetus?
Yeah, so Iron Bank, the reason we went with them is because anything that got through their pipeline, which has a bunch of like, not CSVs, but like a bunch of security scanners, like anything that makes it through that pipeline and gets approved was automatically approved for our air gap system. And so we wanted to get our packages approved through that pipeline so that we were able to pull them across that gap and use them in the secure environment.
Okay.
Yeah.
So they needed something specific based on their security.
Correct. Yeah. We also wanted to make it useful for the community in general, which is why we decided to have this intermediate step of this meta manifest, because this contains anything that you would ever want. Well, anything that Conda has available about that package, and you can just use that as, substrate to create whatever document you need.
Yeah, that's pretty cool.
Yeah, thank you.
I have a question.
Sure.
So how does this work if you don't pin every version?
Sure. So it'll work just like any other Conda solve will work. So like, for example, here, if I don't pin like Python, it'll try to just grab the latest version of Python. So I can show you that, but like under the hood, all this is doing is a Conda solve on this file.
Yeah. So then you put that in the output folder, right? So you'll have like, let's say you'll have a Python 3.10. And so when you use this channel, would the Python 3.10 be considered like the latest?
Yeah, so when you, that's a good
Months
question.
From now, is it always considered the latest?
So in this case, it's what's considered what's available. So for like Linux 64, if we look at the look at the repo data here. That's very messy to look at. But
Yeah, I think
yeah. So it gives you a subset of the repo data.json, right? And so the only thing that's,
Yeah, so basically it reproduces the solving process at that moment. It's like you captured the solving process itself. And as long as you point to that channel that you created, it's just gonna work the same way. Whereas if you were on the internet, then the solving process may not be exactly the same.
Correct.
6 months from now.
Yeah, so like as long as you have like this local channel saved, like as a tarball someplace, like your environment will be exactly reproducible because your repo data.json is frozen in time as well as your packages. And that's like another nice thing is that it also reduces the solve time. So once you've done the upfront solve time, like there's only one version of Python inside of here and one version of all the subdependencies available in this particular channel. So it solves essentially instantly.
Thanks.
Yep. Any other questions? We did want to mention a tiny bit about the roadmap. These are kind of just thoughts that are flowing in my head at the moment, but right now it'd be nice to be able to do this process without downloading the packages, which can get very large. So for example, like I'm using this right now to do this process for PyTorch, and every time you like run it with PyTorch, it downloads like 7 gigabytes of data. But in my case, I only need the repo data.json for my particular process. So it'd be nice to have kind of like a, repo data only option. And then the other thing I've been thinking about is to switch out the vanilla Conda solve with a Mamba solve. So I don't know if you all have heard about Mamba, but it's the Conda solve logic, but it's written in C. So it's like way faster, and it also gives you a lot better like error messaging if your packages aren't compatible with each other. That's kind of some thoughts, but I welcome any further questions. And also this is like how to get to the repo with Conda-Vendor, and it's open source. So if you want to contribute or use it, that would be great.
Yeah, thanks for the talk. This seems like a really cool tool. I think my packaging needs aren't always this complex, but it's a nice tool to have on the shelf if it ever comes up.
Yeah.
And I think the demo really helps kind of visualize how it works as well.
Yeah.
So thanks a lot for walking through it.
Yeah, of course. Appreciate that.
Just to have a curiosity here. So couldn't you achieve this same functionality by kind of hooking into the Conda caching mechanism? Like Conda if you can, let's say you as soon as you issue an install, a Conda environment installation process, it's gonna want to look into some kind of cache directory if it's available. So I'm just wondering if you can just hook into existing Conda instead of having to install like this separate thing. Or in case of
So just so I understand your question, like instead of doing it via the Conda channels, you essentially are going to like transfer a cached created Conda environment, right?
Yeah. Yeah. Somehow you just kind of record whatever Conda does as it's doing it and just dump that into like a cache directory, which I think it's already doing that.
Yeah, so there are tools out there that do that. I think one of them is called Conda Freeze, if I'm not. Yeah, there's essentially ones out there where you can tar up your solved Conda environment and like transfer it to another computer and then you can like unpack it, and it will like fix all of like the headers and the files so that like the new computer can use it properly. So we did, think about that as an option. The issue there though is like, what if you want to add like one extra package? So like, let's suppose we have like pandas and we have, matplotlib, but now we want to add S3FS. There's not really like an easy mechanism there. Like if you have, first environment with pandas and then you like bring another environment with S3FS, like what's the mechanism to integrate S3FS with your existing first environment? And Conda, like,
I still can play around with intercepting like package requests somehow. Like some kind of, if you have like a service, like it's kind of like proxying. It's like something that just capturing like your requests. So you can use Conda normally, and then you have a thing that's capturing things on the way to the internet, and then that becomes the base that you use to cross over the air gap system. Does that make sense?
So if I understand, you're basically like kind of sniffing almost at like the URLs it's using to download, and then using that as the basis for like your security document as well as what you want to pull across the gap.
So that you don't have to go through this extra process. It's just, you're just kind of intercepting and proxying. That's it.
That's true. However, if you you'd have to have some sort of mechanism to like get it back into the structure so that you could Conda install it, right? So like in order for Conda to do any sort of install, you need to have a repo data.
Yeah, but the test would be if you point it, so once you're done installing stuff normally, then the test would be if you can just point it to the thing that was capturing things along the way, the proxy thing. If you point it to that proxy thing, and then it should be able to just install it in the same way. You're just switching the pointer from the internet to the thing that was just watching you.
Well, so like when you download from the internet, it would download the repo data, and then it would use that repo data to solve your environment, and then it would download like these, tarballs essentially, right?
Yeah.
So then you're saying, okay, we have the repo data, we have the tarballs. Do you want to do like a normal Conda install with those?
Yes.
Okay, so the issue with that is, unless you modify this repo data, when you do that new Conda install, unless it happens to solve the exact same way with this repo data, the repo data is going to try and tell Conda to install packages that weren't downloaded. So like the first time you do it, it might work, but if you add like another package version, like S3FS, for example, it might give you a slightly different solve, in which case it's going to say, okay, I wanted, pandas 3.11, but we only sniffed out 3.10.
Yeah, I think I see it.
So like the repo data.json is actually like kind of the biggest secret sauce of this package. So like the repo data is like really finicky. So you like in Conda, there's this, let me see if I have it here. Okay, let's do that. Test 2. Okay, Conda Index. All right, so for all intents and purposes, this is now a Conda channel right here, right? Let's look at the tree here. So when you do Conda Index, what this does is it will look at any existing packages in the directory and then create all of like the Conda like infrastructure files that you need in order for this to be like a Conda channel, right? So what makes a Conda channel is you have like the structure of the architecture's files, like you have Linux 64, no Arch OS X, and then the corresponding repo data for the packages. one thing we tried to do initially was just download the packages that we wanted and then run Conda Index and have Conda create the JSONs. But the issue with that is that Conda doesn't just use Conda Index to create these JSONs. It also has like a secondary step to hotfix the repo data.json to make sure the packages all solve properly together. And that's actually like this link here. And so our solution around not having to deal with these hotfixes was saying, okay, let's take this repo data that we know that works, and we're just going to like filter it down so we don't have to worry about modifying the repo data. We're just going to create a subset of the repo data that we actually care about, and then ship that along with the Conda channel. So your method might work, but you would almost surely run into issues with the repo data hamstringing you there.
And so how are you adjusting the pointers for the repo data that you're creating? How does it know? How, like, instead of fetching a URL on the internet, how do you switch it to a file?
Just like this. So you can specify like a directory. So if you give like the environment, like, so if you do conda install -c and you give it a path to your local file system, it will, if that's a Conda channel, we'll use that as a Conda channel. Like the only difference is that when you, and maybe Conda info even shows this. Conda info. I think Conda info tells you, yeah, your channel URLs. I'm not sure the exact mechanism, but there's like a alias where it's like, okay, if I say main is going to go to this channel URL. If I say Conda Forge, it'll go to like the Conda Forge URL. But if you give it like a local path, it goes to your local path and uses that as the channel.
Got it, thanks.
Yep. And so we even have, like we added a feature in here so that if you want to like auto-generate this, you can. It's like in Conda-Vendor, there's this local YAML option. And we can pass it the path to the meta manifest. What's it called? Oh, I'm in the wrong directory, sorry. And then if we look at this file here, no, that's not it, sorry. Maybe I call it environment. Okay, here we go. This is now like the YAML file for this specific environment. So like if I ran conda install, like in this particular directory and passed it this file, it would install all of these things from my local channel.
Yeah, that's the smallest channel I've ever seen.
Yeah. And that's also like a, I don't know, like I mentioned before, you have, if you do sh, I think it is, we can see that this entire channel is only 300 megabytes. So like our flow right now is like, Like if we have a version of PyTorch we want, we'll create a Docker image with that specific PyTorch channel and then like ship that across the gap. And then we'll do the same with like Viz libraries and then ship that across the gap. And then across the gap in the future, people can just like use those channels as substrate to install whatever they want from them.
All right. Well, thanks everyone for attending. As I mentioned at the beginning of this demo has been recorded and we'll be posting it on MetroStar's YouTube channel probably next week. So if you didn't get to see the full thing, you can check on our channel for the full demo and you can see it there. Otherwise, thank you for joining. Make sure to keep an eye out for future meetups that come on. We're hoping to have one the first Thursday of April, and we are always looking for new speakers to be a part of this group. So if you're interested in speaking, please reach out to MetroStar Systems. You can go straight to our website on our contact us form, fill that out and just say that you're interested in being a speaker for PyData, or you can email marketing@metrostar.com. But thanks everyone. Have a great night.